Hello, good morning. Welcome to today's class. We'll be looking at mathematics, and in mathematics, we'll be looking at a particular topic known as matrices. Now, in matrices, I'll go very quickly because I don't want to tire you with a lot of information. So we'll just go straight to the point. And in the objectives of today's lesson, we're going to be looking at the introduction. In the introduction, we'll look at the definition of a matrix, order of matrices, and notation of matrices. In the objective number 2, we'll be looking at the algebraic operations on matrices, and in that objective we are going to add and subtract matrices. We are going to multiply matrices. There are two types of multiplication of matrices. We can multiply by a scalar and we can multiply by other matrices. In the other objective, we'll be looking at types of matrices. There are several types of matrices, and that is what we are going to look at and I will show you examples of such matrices. In the objective number 4, we're going to look at determinant of a 2 by 2 matrix. And objective number 5 is the inverse of a 2 by 2 matrix. Number 6, we'll solve a simultaneous equation using the matrix method. And finally, I'll show you a formula that no other teacher in class will ever teach you. This formula, it's known as the Cramer's rule that you can use in solving a simultaneous equation. So let's get straight to the point and start with the introduction on matrices. So in the introduction to matrices, we'll think about the definition of a matrix. Now, when we talk about definition of a matrix, I can tell you that a matrix, if you were to explain a matrix to anyone who have never gotten into a class of matrices, you will tell them that it's a rectangular array of numbers, objects, or symbols. So if I say rectangular, you can think of such a rectangle. You can also think of such a rectangle or such a rectangle. This is a square, but it's also another type of a rectangle. So if I say it's a rectangular arranged number of symbols, you can think of it this way: A, B, C, D, E, F, G, H. So these are different letters that are arranged in a rectangular manner. You can also think of numbers that are arranged in a rectangular manner, such as this. This is also another example of a matrix. And you can also think of this. This is arranged in this form. So if I say a rectangular arrangement of numbers, that is what you can think of. So a matrix is such an object. It's such an arrangement of numbers, symbols, or objects. So in number 2, we'll be looking at order of matrices. The order of matrices is how the letters or the numbers or the symbols are arranged in the particular matrix. So if you think about this particular matrix, if you want to give the order of this matrix, you can think about how they are arranged. How many rows does it have? And how many columns does it have? So think about this. It has 1, 2. It has 2 rows and it has 1, 2, 3, 4 columns. So it has 2 rows and 4 columns. So if you ask about the order of this matrix, you'll see that it's a 2 by 4 matrix. It's a 2 by 4 because it has 2 rows and 4 columns. If you're asked about this, it's the order of the matrix is 1, 2, 3. It has 3 rows and 3 columns. That is 1, 2, 3 by 4. So it's a 3 by 4 matrix, and so on. If you're asked about this one, you can say that it has 2 rows and 2 columns, so it's a 2 by 2. Oh, this one is a 3 by 3. Sorry. So it's a 3 by 3. This one is a 2 by 2, and that is what we can think of. So that is simply the order of matrices. So if you're asked about any particular matrix, you can have a 10 by 20 matrix and so on, a 100 by 100 matrix, though I guess it's very hard to get that drawn on a piece of paper. So lastly, we can go to the notation in the introduction, how we denote a matrix. A matrix can be denoted very easily. It's simply denoted by a capital letter. So if I tell you, give me matrix P, you just give me matrix P, which is A, B, C, D, or matrix Q, which is 1, 2, 3, 4. Any arrangement of matrix, so we can give this a name, we can give it A, we can give this B. A matrix is just denoted. So the notation of a matrix is how it is denoted, and it's denoted by a capital letter. So let's move on to the objective number 2, I told you I don't want to tire you with a lot of information on matrices because I want you to get precisely what is most important. Now, let's get to the objective number 2, the algebraic operations on matrices. Now, if you think about the operations, algebraic operations are addition, subtraction, division, multiplication, and so on. So, addition of matrices. So let me get just an example of a matrix. An example of a matrix such as 1, 2, 3, 4. Of course, you can't add matrices with the letters, but I'll show you how you can add them. So if you are told to add matrix P, which is that, and matrix Q, which is 2, 7, 10, 12. If I tell you to add matrix P plus Q, this is simply how you add them. So you just come, matrix P is 1, so you take at each element of a matrix, you just go to that element and add to the one that they correspond in the other matrix. So you go 1 plus 2, which will get 3. 2 plus 7 is 9, and 3 plus 10, 13. 4 plus 12 is 16. So P plus Q is simply 3, 9, 13, 16, which has 2 rows and 2 columns. So this one is also a 2 by 2 matrix. I guess you're seeing it now. So simply addition of matrices is very simple because you simply add what the elements that correspond. If I give you a 20, 1, 12, 16, and a 2, 9, 24, and 8 matrix, and I tell you this is matrix A and B, and I tell you to give me matrix B plus A, you'll just come to B and add A. This is 2 plus 20 is 22, 1 plus 9 is 10, 12 plus 24 is 36, and 16 plus 8 is 24. So matrix B plus A is simply this. And you can add matrices of any order. Now, we are done with that because I said I want to be very precise and very simple. I'll go to subtraction of matrices. You can simply subtract matrices this way. If I'm given 20, 12, 4, 8, matrix B and matrix A is 2, 16, and 1, then this one is 10, and I'm told to give matrix B minus A. What will I do? I'll simply go the way I did addition. I'll just come to B minus A is 20 minus 2 is 8, 4 minus 16 is negative 12, 12 minus 1 is 11, and 8 minus 10 is negative 2. So this will be matrix B minus A. Addition and subtraction of matrices are very well correlated. So you can just get it just the way you add it, you can just subtract that way. So we're done with that. Let's go to multiplication of matrices. So matrices are multiplication of matrices. So if we want to multiply matrices, let's think of a scalar. What is a scalar? A scalar is any number that is a whole number or a real number. So if you think of a real number as a scalar, such as a scalar k could be 1, 2, 3, anything to 1 million. So if I tell you to multiply any matrix B to get bk, but let's say k is equals to 4, and I tell you matrix B is equals to 1, 2, 3, 4, 5, 6, and I tell you to multiply, to give me KB, matrix KB, which is multiply this by the matrix B. What will you do? You will simply go to the matrix itself and multiply every element with the scalar. This is how you do it. K is 4, so K times B is 4 times 1 is 4, 2 times 4 is 8, 3 times 4 is 12, 4 times 4 is 16, 5 times 4 is 20, and 6 times 4 is 24. So this matrix KB that we got from multiplying this matrix B by a scalar K, which is 4. So it's that simple. You just multiply every element of the matrix with the scalar. So let's go ahead to multiplication by other matrices. is particularly where I want you to get to understand, because this is a bit more complicated than the above. So you just don't multiply every element. So this is how you do it. Let me give you a matrix A, which is 1, 2, 3, 4, and matrix B, which is 1, 2, 6, 3, 2. So if I give you this matrix, matrix A and matrix B, and I tell you to get me matrix A, B, which is A times B, how do we do this? We simply come to matrix A and multiply it to matrix B, which will be 1, 2, 3, 4, 2, 6, 3, 2. Then I'll take these two matrices and multiply them. How will I do this? I'll multiply, to get the first element, I need to get another matrix A, B, C, D. To get the A, I'll simply come and get A is equals to 1, this row multiplied by the first column to get element number A. So how will I do this? 1 times 2 is 2, and 2 times 3 is 6. So I'll just come and add that. This is 1 times 2, then 2 times 3. I'll simply come and get element A. To get element B, I'll come, take this row, multiply by this column. I'll come, 1 times 6 is 6, plus 2 times 2 is 4. Then to get element C, I'll come and take because C is on the rower column and on the first column, on the rower row and on the first column, I'll come on the